Hi, everyone. Hope everyone is well out in the world, wherever you may be. Today, I'm Jim McGuire. Today, we're going to go over some pressable materials made by VITA, Germany. And we're going to talk about the just step-by-step, the process flow, and then get to any of your questions that you may have at the end of the program. So just a few housekeeping items first. Everyone's phone is currently on mute. So if you have a question on that pop-up screen that came out on the right-hand side of your screen, go ahead and touch on the question box, type in your question, and then send that to me. And then at the end of the program, I will address any of the questions that you may or may not have, okay? So there will be a Q&A at the end of the program. Those of you need to go back and review again. We are recording like we have on all of these remote webinars. We record them and post them on our VITA YouTube channel, VITA North America YouTube channel. There are probably 100 or so webinars, various types, various subject matters that we've been doing for the last year and a half, 2 years since COVID started in 2020. So please visit us. We don't do CE online. However, you can certainly find some additional information, methods, processes, anywhere from ceramics to digital denture teeth, pressing, and so forth. So go visit our VITA Learning website, which is also on the VITA North America website. There will have some additional topics and additional webinars that we recorded as well. But for the most part, just go to the VITA North America YouTube channel, and we will have this on there in a couple of days. So today's title, Lithium Disilicate, Pressing Workflow. So we're talking about pressing. I know that there's a lot of pressable materials out on the market. Most are lithium disilicate. I'll kind of go over at least the VITA, what's called the Ambria material. The Ambria material itself is a lithium disilicate glass ceramic. It's reinforced with some zirconia particles. And the zirconia is not really like what we do for framework zirconia, but it is, it's a broken down oxide type zirconium in which we dissolve in the solution, and then it uniformly populates within that matrix of these pellets that we produce. And within that pellet, it reinforces it, adds a little bit more strength to it, and I'll get into that as well. The Ambria, they're kind of like a amber color. They do look a little bit odd, if you will. They're almost see-through, so until you press it, until it reaches its maximum temperature, 880, 890, around that neighborhood Celsius, then it will transition over into the shade that you have requested. But they do look a little bit different. We got plenty of shades. We've got the classic and the 3D master. We've kind of designed the shades so that you don't have to have every specific shade. We don't have all 16 classical shades, but what is missing, you can make up using the closest shade and then use what we call the chroma stains, the VITA chroma stains, and use those to change the outcome at the end. For instance, on the 3D Master, if you're used to that system, that's an alternative system. We have 0M1, 0M3. In our system, we have a 0M2, but you can take the 0M1 and add a little bit of stain called the chroma stain and make it into a 0M2, no problem. And then we made most of our, at least 3D Master shades, most of the materials now at least come in starting with the 1M1 and then the 1M2 group, but then the 1M2 or 2M2, 3M2, 4M2, those can always be changed to a 3, 1M3, 2M3, 3M3, etc. So anything in between, just use those chroma stains, and I'll show you a little bit about those in a second. These are very equivalent to the, at least the translucency, they're equivalent to like the Emax press, Lithium press. We have a translucent, in which is kind of like the LT of the Emax, a high translucent, the HT of the Emax press. We also have enamel replacements. Those are called the ST or super translucent, and those come in the colors of different chroma intensity. So we have a light, medium, and then intense of that particular color. So it'd be, think of it more of the light as being maybe the enamel of shade A1, and then the medium, maybe the middle third of A1, what it looks like, and then intense would be more of the chroma of an A1 shade tab. And then next year, we're hoping that by CDS, by LMT Chicago, which is usually our major trade show of the year, start off each year, we expect possibly to have a medium opacity Ambria solution as well, which would be fantastic. Sometimes the T is too opacious, HT is too translucent. Some people are looking for something in between, and a medium opacity will fit right in with the other materials. They do come in a small and a large size. So the small, you can wax up and about 0.75 grams, which is equivalent to maybe 2 to 3 full contour restorations, wax restorations. Of course, you're always going to make sure there's enough for the sprue to adequately keep the pressure on while it's being pressed, that it has extra material, a little bit of extra material to keep that pressure and make sure that it flows into the cavity and presses complete all the way down to the margins. And then you got the large one as well, which will go to a 3-unit bridge, 3 to 4 full contour, maybe molars, and so forth. So the sizes are also part of the mix, where you can kind of choose which one's going to best fit whatever press you're pressing. The one thing about VITA that you can always rely on is that shade consistency. So the shades that we call out on the packaging is a true VITA gold standard shade. They match up with that shade tab. However, one should know or recognize that when VITA produce these shade tabs, some of us older technicians like myself, we used to, in the past, in the 80s, 70s, 80s, 90s, we used to take our shade tab and cut off the cervical, cut off the incisal, use that middle third as the base shade. And that's really where the basic gold standard shade is of every shade tab that VITA produces. The shade tabs themselves, those are made out of a specialized metal ceramic. And if you measure them, they're about 4 millimeters in thick. So it's got an opacious pellet in the center of each shade tab. And it used to be hand layered all the time. Now they're automated. But your true middle third of each shade tab, that is where you get the exact gold standard. And that's what we're trying to match up when you compare it to a shade tab. So make sure you remember that, and then we can always stain it down, stain it up. I mentioned a chroma stain. I'll get in that in a little bit later, but the chroma stains will just add a touch of more chroma. As far as the material itself, the Ambria, what makes it a little bit different? Well, it's got a very finer grain size as far as the particles, the crystals. The crystalline structure is less than 3 microns long, those little needle-like lithium disilicate makes up as it transforms into the final product. These are crystalline structures. They're kind of needle-like, but they're less than 3 microns. So they align up more closer, tighter knit than your larger grain size particles of maybe some of the other lithium disilicate materials. Those are a little bit longer. Some are almost twice as large as ours. So it's a little bit less, ours is a little bit more polishable. Theirs may be a little bit less polishable. Ours is a little bit stronger, and I'll talk about that in a second, and so forth. And it's really due to how we manipulate and control that grain structure of this material. It does come pre-crystallized in a sense because it's got the form, so it's partially crystallized, partially sintered, if you will, and then it transforms completely during your press process, of course. It's about 12% of zirconia oxide added into the mix to add a little bit more strength. The rest of it, the majority, of course, is a silica oxide, and then you got the lithium dioxide as well. So it's very nice material, and the mechanics side of it, because we're all conscientious now about, well, what's the strength? Because we've been kind of, I hate to say the word, kind of indoctrinated in our dental market now that we're always asking about the strength. For some of you who are not aware, when we're talking about the strength, primarily most companies market the strength of what amount of pressure, weight, loads it takes to start a fracture of maybe a disc, which is usually called biaxial strength, or a rod or a segment that's about 10 millimeters long, maybe about 1 millimeter thick, and that's a 3-point fracture load test. And so there's different test methods. And so when you start seeing strength, that's usually what it's talking about, not the strength of the final restoration in the design or the form of a crown, but rather the strength of international standards, if you will, of each ceramic material. It has to reach minimum thresholds to be able to commercialize. And so just remember, the strengths are pre-designed, pre-wax, anatomically correct, if you will, and are only test specimens that they go through a specific test. Your biaxial test, because it's like a quarter size diameter, as opposed to a 3-point bending that uses just a rod or a stationary platform. The biaxial loading, the discs, there's more surface area, there's more material. So when the pressure is placed on this material, it takes more load to actually cause it to fracture versus just a static squared off platform, if you will. So your biaxial strength is always going to be higher than your 3-point bending fracture load. So if you're looking at different specific strengths and stuff, just make sure you know what type of testing they're talking about and so forth. Now, we've always benchmarked. VITA's been good at benchmarking a couple things. One is the shade for sure. The other is the opposing dentition to make sure it's antagonist friendly. And then the other thing, of course, is maintaining that it is structurally consistent from batch to batch to batch to batch. And then we've also made sure that it is within the load capacity of the average adult chewing, which in this case, by research, a lot of it done by with implants more than anything, occlusal forces in the posterior average about 490, 500 newtons in the posterior. So we try to make it so that we have a higher threshold of our material so that there's a safety, if you will. So here's the 490 line. So all the testing that we've done, and we've averaged it out to, over 1,000 newtons. But the lowest, of course, is 800, which, is a 2/3 more than what the 490. So it's got a good safety margin, and then you've got others scattering that are even higher, close to even the 1,200 mark of loads of newtons, which are getting pretty close to what a Bruxer would be. So it's a very strong material. There's also other things we can do once we press these units. Once material is pressed, it comes out, the surface, it comes out a little bit more rougher because of the press itself, the molten, the consistency, the viscosity of your press material as it presses into the cavity, and then also depending on the whether your investment is of higher quality or not. It comes out cleaner, smoother, but it does, the smoothness itself will affect for any type of material, whether it's CAD/CAM, whether it's digitally designed and then digitally milled, and or press, or even layered in a sense. The outcome is that the surface is important to have a smooth surface, only so that you help strengthen it. So what you look at is, this is a picture of the pre-press material, and under the wax you can see little lines and so forth. But then when you press it out, you still have these little lines of tooling marks of how you did or didn't smooth out your wax, and then also the roughness or smoothness of your investment, as I mentioned earlier. So what you want to do is make sure that you don't have a lot of score lines, or what I would call Nazca Peru, those Nazca lines. It looks fancy, it looks nice, but when it comes down to strength, you need to make sure that you smooth out your wax the best you can prior to pressing, and therefore you have less work polishing after it has been pressed. Now, the other thing that it does is that we recommend that after you press it and you cut the screws off, and before you get going, we recommend that you place that restoration back in the furnace and do what we call a tempering or a power glaze. And what that does is it's at a lower temperature than the press, but what it does is it actually will help smooth out the surface after it's been pressed, and it'll smooth it out, and all those peaks and valleys of your surface microscopically, they'll smooth it out, and the smoother your surface is, the stronger your material is. So we can elevate our material strength from an average of 500 and go up almost 550, and it has what we call a very small deviation. So we can increase the strength by doing this tempering or power glaze. It's a simple process. It's just an extra firing, but no problem. VITA also makes your materials and the color very stable, so you can multiply fire these materials without losing, distorting or losing any consistency with shade and so forth. So make sure you temper it if you want that extra strength. It does get up to about 550 before and after. If you look at the pellets, you can kind of show them up to the light, and you can see all the opalescence and the red and blue waves coming in, light waves from that opalescence and opalescence. And that's before you even press it. And then after you press it, it's maintained a lot of that opalescence and fluorescence. It has a very natural fluorescent image to it because it does have zirconia ingrained in it. It's a little bit less fluorescent than a natural tooth. However, there's always ways to add to it. We're almost always glazing these pressed materials, adding stains and glaze. And by using the glaze, at least our VITA glaze, even though low temperature, you can increase the fluorescence. And then we have actually something called the Fluo glaze, which is a spray. It's not a powder or paste, it's a spray. But I think zirconia-wise, it'd be a good idea maybe to use this Fluo glaze, low temperature. LT stands for low temperature. These things glaze at around 800 Celsius. But you can use that Fluo glaze and really create more and more fluorescence as needed. So if you ever have something from the dentist asking, well, how fluorescent is it? You know, depending on how fluorescent they want it, you can always increase it. But by itself, on its own, it does have great fluorescence compared to other materials that we have. Mark II, of course, is a millable feldspar material, which is very fluorescent in itself. But comparably to other competitors, you know, we have a good fluorescence naturally built in. So once you've pressed it out, you can stain, you can glaze it. You can do that power glaze, that tempering. But you also want to have an opportunity to also micro layer to it. That's really what we're doing nowadays, right? We're doing micro layering of zirconia, micro layering of pressed material, or full contour on the pressed material, or full contour in zirconia. We're getting better and better as manufacturers go, the industry goes, we're getting better and better at making these alternative materials look more natural on their own. However, the Ambria material, if you want to micro layer it, we have something called Lumex AC, which is a low temperature porcelain that is basically universal. It can be used on the Ambria. You can use it for zirconia. You can use it for a titanium abutment, your Lithium, your Emax press, and so forth. So this is virtually a ceramic material that can work on multiple frameworks. However, depending on the framework you're going to add it on, you're going to change a little bit of your layering technique, if you will, because certain frameworks, materials, they've got different translucency, right? Even on your zirconia, for instance, if you take a very low, old school translucent zirconia, you're going to layer that a little bit different than you would if you had a very high translucent zirconia that we offer today, you know, that's sometimes up to 50% translucent. But this material, like all VITA ceramics, they're very stable for multiple firings. Even at this low temperature, it was very important for VITA to come out with a ceramic that could work off of different framework platforms, but also would be stable across the range, the low-high range of all these materials that you want to veneer to or micro veneer onto. The Lumex AC, it's got every nuance color if you want. There's a lot of gingiva colors. There's like 8 different gingiva colors. So if you need to recreate a gingiva collar around your pressed material, your bridge, if you're missing soft tissue and you need to recreate that soft tissue gingiva sculptured area, you can do that with these gingiva porcelains. There's also all these different translucent powders. If you're micro layering, really we're just working without, the dentin itself, the material itself acts like the dentin. The press material is the dentin, the base shade. You really don't have to add additional dentins to it to acquire that shade. Really what we're doing when we're micro layering, we're talking about adding certain percent of translucency, or a degree of translucency, or a degree of opacity in contrast with that shade, that specific shade. And again, the middle third of your shade tab is the exact shade gold standard for VITA. So your incisals, your cutbacks really should be from the top echelon of that middle third and above up into the incisal that you're going to cut back if that's what you decide to do is micro layering. There's different translucencies, again, depending on the framework, the canvas. You're going to use different translucencies, different enamels, different nuanced colors, and so forth. That you're going to match it up. Some materials are a little bit grayer than the comparable to a shade tab gold standard. So maybe you need brighter enamels to brighten it up, and so forth. Maybe depending on your translucency of your zirconia, if your zirconia is very high translucent, it's a little bit more grayer as well. So maybe you use more brighter shades. On the Ambria, the excuse me, the difference between the T and the HT are such that depending on the thickness, that you would also maybe use different brightness of enamels as well if you're going to micro layer the Ambria, the press material. Like most different translucency, high translucencies, your Ambria T is translucent, but generally it's for semi-masking the canvas, semi-masking the prep shade. So there's a little bit more, opacity to a translucent pellet. The high translucent is used for a little bit more, less thickness, if you will, but also on the full crowns that maybe the underlying prep shade is ideal. And you really don't have to change or mask out that underlying canvas or prep shade, which is something you should always look at. What is that color of the prep before you start doing major work on either micro layering and or staining glazing, especially on translucent materials like pressed material, a lithium disilicate like Ambria. You really got to know what it's going to look like on the clinical side before you start doing too much to it. And as I mentioned, depending on the canvas, the substructure, the framework material, you're going to change up a little bit of that layering scheme as needed, because they all have different light transmission, a degree of it. They all have a degree of different reflection, refraction, and so forth, absorption, and so forth of those color wavelengths. So again, depending on that canvas, depending on that framework, you need to modify maybe your Lumex AC addition, micro layering. And again, same with the Ambria. This is compared to a natural tooth. The Lumex AC is very highly fluorescent and so forth. So it's a very nice material all the way around. Now, to get back a little bit back to pressing, we knew that we're not going to recreate the wheel here. Our emphasis is the shade consistency, the shade offering, the strength. And, these have, this Ambria has everything that you need for those to meet those requirements. The process itself is pretty much the same. And anyone who does a lot of pressing, you know that there are certain guidelines, there are limitations. You have to have the margin at a certain thickness to do a complete press. You have to have the restoration when you sprue it. You know, think of it as a flower coming off the sprue. It has to flow out as even as possible without hitting right angles. So it's got to have a nice flow. If it doesn't, then you sometimes find yourself having to increase the temperature, the press temperature, but that can start affecting the shades and also start affecting that reactive layer that naturally occurs with lithium disilicate. There's no way 100% completely around that reactive layer, that whitish material, but there is like investments. The Ambria investment itself actually helps you alleviate that material. So same thing as everything, right? Different shrinkage, different pattern, different thickness. You might want to adjust your different water liquid ratio for the investment. You're going to make sure that you sprue it correctly so that you don't have micro fractures during your process. Everyone is that gets into pressing a new person, they're kind of surprised how finicky, if you will, or how technically challenged your investing and heating process is to have a successful pressed unit. All of us have gone through multiple of press rings that are fractured, and they fracture for a reason. Either we violate the area in which we need to surround the pattern. We don't have enough investment around the pattern. We're too close to the edge of that former, and it can cause microfracturing. We inadequately sprue it correctly. It doesn't flow nice, and so therefore it's got a choke point, in which that choke point builds up a lot of pressure, and if that material can't flow through it, that choke point is going to cause maybe too much pressure, and it will start blowing out the side of your ring. So there's all sorts of different rules when it comes to pressing. And since we're always doing ringless, you know, the old school PFM where we have the metal ring, you know, we're basically doing quick set investment, and we're doing it rapid heating, rapid processing of these rings. So there's thermodynamics of the investment curing as well. And so there's certain rules that we have to adhere to. We help part of that with little matrices that we have that you can put onto your ring and kind of make sure that the angles are there. That will help. So, you know, you just make sure you use these tools that a manufacturer can provide, and those will help you ensure that you've got enough distance from the wall of your muffle or your former, and so forth. So the rest of it's going to be up to you, how smooth you're making the wax transition, the sprueing. This part, the process is still the same that you're used to. You invest it using a certain amount of water liquid ratio. You're letting it sit, bench sit for 6 to 8 minutes, and then you're going to scrape that up. And you can go all the way up to maybe 20 minutes of bench setting, but don't go beyond 20 minutes. You should be able to, when you remove the ring from the former, that ring, that investment ring, should be still hot. And if you turn it over, you would almost see your wax is leaking out because of that thermodynamics, the heat that it's already starting to cure and creating. And you don't want to put a cold ring in a hot burnout furnace. So if you're not watching, pay attention to the amount of setup time and placing the ring in your burnout furnace at the appropriate time and temperature, what you do is you end up maybe shocking the investment, and that shock from going from a colder area to a very hot burnout furnace, 700 degrees, 850 degrees Celsius. What happens is that it'll shock it, and when you go to reach in and you grab your ring from your burnout furnace, you will actually see it radiates a bunch of micro fractures. And any one of those little micro fractures that's been created is a weak point. And if that, during the press process, if there's enough pressure, it just basically takes those micro fractures and blows them apart. So it's not the investment, it's not the furnace, it's not the the material itself. It's mainly the process that we have to pay attention to. And I can tell you, being in enough laboratories that do hundreds of pressed rings every day, have multiple press furnaces, the one thing they all have in common is that they have an additional burnout furnace that is of a lower temperature, and they go from the investment stage, remove the muffle, and then they take that ring without the muffle. They take the ring and they put it in this lower temperature burnout furnace to maintain, maybe they go down to about 700, 650, 700 degrees. They maintain it in there for 20, 30 minutes. And then they move from that lower temperature burnout furnace, and then they migrate it, move it over to the correct furnace, burnout furnace, to achieve that 850. And that way it has a nice transition from investment to a burnout, and then to the subsequent high temperature to burn out all your wax and residue. And you have less likelihood of causing microfractures because of that thermal differentiation, if you will. So this is something that's very important. And then, as I mentioned, if you are pressing too hot versus too cold, this shows a 20-degree swing, both higher or lower. This just shows at the right temperature, we've made these materials so that after you press them, the crystalline structure, they kind of morph, they realign, and then you're talking about more of how the crystal structures line up and begins to refract and absorb and transmit light to get the correct shade. If you're too high in temperature when you press it, it will actually change noticeably the color of your press units. It's not as bad if it's colder, but definitely when it gets too hot, up to about 20 degrees too hot, anywhere above 10 to 20 degrees too hot, you're going to see a significant change in your the color, which of course is not good, since shade is supposed to be very consistent and very accurate, since that's what we're basing everything on. You want to check your furnaces. Your press furnace is no different than a ceramic furnace, so you want to make sure that you're adjusting it appropriately as the muffle ages. If you need to do a window or a clear porcelain, make sure that it is the correct firing temperature, the thermocouple's good, your thermostat's working properly, and that your muffle is clean. So if you do any other types of materials inside your press furnace, make sure you periodically purge or clean that furnace. we traditionally do a 1,000 degrees, 15 minutes, no vacuum for what we call a cleaning cycle for the muffle, and that pretty much cleans everything out of that muffle, any contaminants and so forth. If you don't, no matter what we do when it comes to ceramics, anything pressed material, glass material, it will be discolored when it comes out. These are all supposed to be clear, but only one or two are actually look like they're clear. The rest all have contaminants within that muffle, and it changes more of a yellowish tone, that clear window. And so when you're looking at shade, it could be just contamination of your furnace that you need to watch out for. You can also do a silver test. Silver test is an easy, more accurate way to check your furnace. The VITA furnaces all have built-in cycles for silver test. There's one that will, the first temperature, which is 10 degrees, approximately 10 degrees lower than your melt point of silver. It will make it, the silver itself, it'll start to swell up. And then add another 10 degrees for the second test. That additional 10 degrees should ball up, completely melt your silver, and then you know it's working. So when you come across different changes, the color's off, you start to see fins, you start to see short margins. This could be the heat, the pressing. It could be contamination of your furnace. It could be thin waxed margins that you have a choke point maybe on your spruing. A breakdown of the investment if you're not using clean investment liquid. So you got to make sure if you see any of those, like anything else that we're used to in the dental lab business, anything that's a liquid, if you ever see particles floating around, you got to get rid of that. It's time to get new stuff. Otherwise, it will not bind the investments correctly, and it'll break down. And under high pressure, that pressing does, it will, cause that to have those microfins. It'll split, cause microfractures, and so forth. So that's something you really don't want to see. Or if you go too hot, or you leave your ring in excessively too long in the furnace, all sorts of things can go wrong if that investment starts to break down, or it's not conducive to a nice flowing direction for your pressed material. So make sure that you cover the bases. And if you call us up, we'll be asking you, well, what is your baseline? What have you started with? We all give recommendations. Every manufacturer gives recommendations on the starting point. There are ways that you can test your pressing process. We have these patterns that you can get that are for like the saddles of a partial denture that we recommend that you place on your sprue. And you press out something and then make sure that that pattern completely presses out, and then we know we're at the right temperature. If you go too low, it doesn't change the color so much. It does become a little bit more opacious, however, but you won't have the defined pressed margins that you need. And then if you go too high, it really starts messing up with the color, but also you have the breakdown of that investment. You have the roughness that's showing up, and you have what we don't want is excessive reactive layering, that whitish material, and then we have to go to maybe a chemical compound to break down and remove that residual reactive layer. So we want to make sure that we are within the zone that is just right. So there are test methods. We can send you this documentation if you want. If you're interested, get a hold of us here. We'll send you, email you out, or you can find it online on our VITA North America website. There's this chart, this little chart that is available. So make sure you do it correct, test it before you get into your commercial work processing. So as far as the press process itself, the only high temperature we change is between 100 gram and a 200 gram. We change the temperature by 10 degrees higher when we do a 200 gram. And then we also increase the heating time, the heat soak time in our press furnace. The press furnace that we have, that VITA sells, it is an air driven, so you need a compressor. They're a little bit, are more accurate than a mechanical, but that's true if you have more dedicated air lines. So if you're using in your lab, if you've set it up where you just take your existing air hose configuration and then hook it up to a press unit, during the time that you're actually physically pressing, if somebody takes their air hose and releases it, or a couple stations have their air going, what's going to happen is that it will diminish the air pressure out of your air piston air-driven press furnace, and it may not be adequate to press it. So what VITA's done is, in their cycles, they've added maybe an additional press time. So the way our furnaces operate is that after you have the hold time, and it actually begins to go into the press process, we set it up so that you have a 3-minute press time. In those 3 minutes, if the pressure is such where that the piston feels that there's no longer any downward movement, it will shift from this first bar, this first press segment, it'll flip to the secondary press, and if it still continues to feel that back pressure, no movement within the piston, it will end. Usually you should be able to have anything pressed out within about 4 minutes, 5 minutes at the max. We set it up so you have a 4-minute process. Most smaller rings, and most even 200-gram rings, they press out less than 3 minutes. But if it goes through all 3 minutes, maybe your temperature is a little bit low, your press material, the viscosity is a little bit more harder, gummy, if you will, and it's taking more pressure to press in that material, it will go through that 3-minute cycle, and then it'll continue on into that secondary press cycle. So it's got like a safety valve there, if you will, as far as the pressing goes. And of course, if all of a sudden you see it, all of a sudden it presses and then all of a sudden quits quickly, you probably have a mispress. So that's where we go back to the process. Are your rings, are you heating up correctly? Are there micro fractures from the time that you take it from your burnout furnace into your press furnace, and so forth? So all this is built into the VITA press furnace. Divesting, I should say, divesting is the killer of this material. This is what takes you more time than the waxing, more time than the investing. Can take you as much time as the actual press cycle itself. This is a pain in the lower rear end for sure. There are, I don't know if they still make it, Whip Mix used to make an automated machine that has spindles that you put the ring on and it would auto divest. But normally we manually divest this. So we just have to sit there, and make sure that we don't overly pressurize our aluminous oxide. Otherwise, this stuff is glass. It's a lithium disilicate. It's a glass material, glass matrix. When you have too much pressure with aluminous oxide, it's hitting against that material, and as it hits, it builds up energy. And if you were to turn off the lights and look at where you're sandblasting, this is true with Zirconia frameworks as well. You got to make sure that you adhere to the low pressure so that you do not create sparking on this material or overheating, because it'll disrupt, it'll change, and maybe fracture your material. So make sure you follow the instructions. You use the proper glass, ceramic, rotary instruments, polishing wheels. In our direction, after you get everything, the sprues cut down, you're just about ready to then start checking shade and so forth. That's when we would throw it into throw into the furnace again for that tempering or power glaze, if you will. The investment itself that we have is reactive layer investment. It's one of the newer types of investments. There's others that have it, but ours is formulated to the best ability to try to reduce that reactive layer. They usually come out fairly clean, even though it's a lithium disilicate using this investment. It's a dedicated press investment, so it's a very firm, smooth investment. So the patterns themselves, they come out really nice without really that reactive layer. And usually you shouldn't have to spend time to put it in a solution to remove that reactive layer at all. So it's good that it's a dedicated press investment material dedicated for lithium disilicate materials to help you with your time saving to remove that reactive layer. As far as that power glaze, it's a 13-minute cycle. I know, it's an additional cycle, but this really dramatically increases the strength, brings it up above the 550 megapascal strength level, flexural strength level. So make sure you do that. It should just be routine, and then you don't have to worry about it. If you don't do it, as I mentioned earlier, it's a little bit lower than if you were to temper it. It's around 500 after this stuff is pressed. If you do not do the power glaze, it's about a 500 megapascal biaxial flexural strength, but it's above 550 when you are talking about after you temper it. So I would recommend that it's always tempered. Just do it, get it out of the way. And then, of course, your wax pattern is pretty much the same as any other pressable material. As a manufacturer, we err on caution. So a posterior occlusal aspect, we've talked about 1.5 millimeters that you should have. It should be the end. If you're doing a kind of micro veneer it, you can get down to about 1.8, 1.7 millimeters, and then add your micro layering on top of it. Can you get thinner than what's listed on this? Of course. We can get down to 1 millimeter, but depending on your smoothness, depending whether you tempered it and so forth, it's always recommended to, if you have the space, 1.5. But again, if you need to get down to that 1 millimeter, that is possible. Whether you decide on this press material, full contour, or you're going to micro layer it, you're going to then press it out. After it's pressed, after you do your power glaze, after you temper it, you can just polish it if you want. You can then stain and glaze it, and or you can micro layer it. So there's different processing techniques with this. Just like most pressable material, you can make it as characterized as or individualized as you think it needs to be, or if you just need to stain it, add a little bit more chroma, you can do that as well. It's a very easy method. If you do stain and glaze it, which most of us do, we use what's called the Accent Plus in our system. This is basically a universal stain glaze, low temperature glaze is used in this case. We glaze this material around 800 degrees Celsius. We have all the different colors like everybody else. You can mix them, you can match them, you can effectively create your own characterization stain color. Most of them, except for your black and your very dark pigmented stains, are all fluorescent. Your glazes, the LT glaze is highly fluorescent to begin with, but you also have additional high fluorescent glazes if you need to use. But these are the different colors, just like everyone else. Different effects, different colors can affect the characteristics, the nuances, the translucency, the chroma, and so forth. If you're just looking to try to get a color to maybe add chroma, then we actually have these chroma stains as well, and they're actually labeled A, B, C, D. So if you have an A2 and you want to add a little bit of chroma A2 to make it more of an A2 because maybe you're thinner on your restoration than you normally are, and the material thickness doesn't give you enough chroma even on top of a prep, then you're going to maybe add a little bit of chroma A. If it's a 3D master, we have those as well. You just add a little bit, kind of make it the right chroma. This material is used for all of our zirconia, all of our feldspathic porcelains, all of our anything ceramic-wise that you mill, Suprinity, and so forth. Those are all used for this to help create it and make it a little bit more chroma. And then I can't stress this enough, that before you start adding stains, you really should, on these translucent materials, these modern materials, that including zirconia now, because we have a zirconia called XT, YZ Solutions XT. That's almost 50% translucent. And you really have to know what that underlying prep color is. So make sure you're always using this like a dye. This is just an indirect composite of the specific shade that the prep is. Just make yourself a quick dye replica of the prep, place your crown on top of it, and then start assessing for your shade or color against your shade tabs. If you don't stain and glaze it, which you don't have to, you can just polish it. We do have a specialized polishing for high zirconia materials. It's the YZ Solutions or the Suprinity Solutions polishing kit. We also have some polishing paste. Now it's new. I still have to put a couple of the images into my PowerPoint still. It's called Cera Polish, C-E-R-A, Cera Polish, and then we have one for our Anamic, our hybrid, which is Cera Hybrid. But the Cera Polish, along with the polishing wheels of Suprinity, we can really make it so that whatever is left over from your waxing, pressing, microscopically, any of those lines, those Nazca lines that I mentioned earlier, we can alleviate those. We can get them polished. We can get the surface smooth. Again, that will help long-term with the strength. It does tighten up the surface tension, so it is possible, though. I would personally, I polish these, Ambria, the press stuff. I polish it, clean it up, then I stain and glaze it, and then I also then come back and buff maybe the luster a little bit off. So as lab technicians, we have a little bit more time than a dentist. So these processes make a much better result. It does take longer, but that's what we do for a profession, right? We make things better. We make things look, blend in naturally, and that's what we're trying to achieve, including the glossness. So make sure you polish it to make sure that those surfaces are smooth. I threw this in here only because there's more and more talk about, oh, well, let's forget about the megapascals of the flexural strength, because now that we got zirconia, you know, if strength is the only end factor, then why wouldn't you use a zirconia? Because that's the strongest material we have. There's a lot of reasons we wouldn't use zirconia, you know, aesthetics, translucency, lifelike, fluorescence, right? But there's a lot of reasons why I would use zirconia. But you don't want to use a material just because it's so strong. There's also something called fracture toughness. This basically is, since the industry is talking about it more, that this is even more important. What it is that any material, once it's processed, basically we, at what point, if the loads in the patient's mouth, if a fracture, the initiating fracture line, if it starts, at what point will it propagate through? So there are many, we see plenty of natural teeth that are fractured, microfractured, craze lines that never fall apart. There are microscopically on the surface, after years of use of these glass materials, no matter what it is, you can find little chips and little shallow cracking. The material itself, it's always trying to resist that crack from opening up or penetrating through the material. So that's called the fracture toughness. So if you're interested, the Ambria is about 2.3. We're basically equivalent with the EMAX. I know it's 0.1 difference, but again, if you look at the deviation, the materials that we produce are a little bit more consistent. So of all the products, let's say you do 100 tests and try to find out what the fracture toughness is, the ones that have the highest measurement, 50% of them, this is the top, that's the 2.3. Whereas here, the 2.4, see how high that deviation is on the increase of fracture toughness, but look how much lower it is as well. So half of these become lower than what it says. So these are averages. So this is pretty close. Our Ambria is pretty close to the a YZ XT, again, which is 600 megapascals and is 50% translucent. So make sure, again, if people ask about different strengths, composition, physical properties, always VITA stacks up very nice against any competitor, and we kind of are either at or above a comparable material, and that's how it's designed. So we have the shades, we have the strength, we have the consistency, we have the processing down, and so forth to deliver the right shade that matches the VITA shade tabs. So our products are sold a la carte, they're sold in kits and so forth. So whatever makes sense maybe to your laboratory. We also have other accessories surrounding the Ambria, as I mentioned. The investment, even if you don't pick up the Ambria, maybe you want to try our investment to see if it helps alleviate, reduce that reactive layer, because it is a really nice investment for lithium disilicate to reduce that reactive layer. We got a very nice press furnace. If you're in the market for one, economically, we can get you into any of these different materials, the stains, the polishing, the material itself. If you need to get a hold of one of our reps, we can provide you that information. Again, email it to us, contact us. We have a help desk. We're here from around 6:30 to 5 p.m. Pacific Standard Time. So make sure you contact us if need be. We can get you in touch with your local rep, and they can kind of help you navigate on how to get into this material if you're looking for that. Those of you that are online, before we get to the questions, those of you that are online, you will receive, through your registration information, you'll receive the information on any CE credits. We do offer an hour and a half, 2 hour CE credits for this webinar, and we will email you and confirm that using your registration information. If you don't receive something within a week, week and a half, then please contact our marketing education department, and we'll look into that and make sure that you get the CE. It has been recorded. I mentioned this earlier. You can find all of these webinar recordings. They're all posted on our VITA Learning website or VITA North America YouTube channel. There are so many categories, so many product lines that we've done. Hundreds of these videos are online, of these webinars as well. We have how-to videos. We have all sorts of different helpful hints and so forth that's available that you can review when you have a chance. You can visit us on our social media, the Facebook, Instagram, LinkedIn, YouTube channel, and so forth. We have additional webinars, subject matters. We have remote workshops. We'll probably start doing hands-on, in-person workshops starting in 2023. I think it's getting time where that we can start doing these hands-on, in-person workshops out in the field, but we will continue. We'll still continue to offer remote webinars. These are highly successful as far as attendance. They give you an opportunity to listen to me or other technicians in your profession to go over materials, how they use them, and so forth. They're very informative. We try to make it less commercial and more informative, more to how-to, more of giving you hints and tips and reasons behind the material. So thank you for joining us today. Please join us for another one down the road. But as far as questions and answers, let's get to a few of yours. I know that there are some that are on the way and that are here. Would it be safe to use non-VITA brand glaze liquid to wash bake before baking? So the question is it okay to use non-VITA glaze liquid to wash bake before baking? I am assuming that's more of your wash bake. There are those that will use glaze, believe it or not. You know, when it comes to zirconia, there are there's usually a wash bake. We recommend a wash bake. There are those that use the actual glaze material, because glaze is nothing more than fine powder ceramic. It's glass, and they will use that as their wash bake. Yes, most glazes are fairly neutral in CTE. I don't want to say yes, go ahead and do that, because my personal opinion, VITA's opinion, is for the wash bake is not to use a glaze, because we want to have a little bit more larger particle size to actually microscopically have some macro texture to it that will help adhere your subsequent layering. So I would use a porcelain, any of your dentins, any of your opacious dentins, your enamels, anything of that nature is what I would use. So I hope that answers that. Do you recommend any burrs that won't cause sparks when cutting the investment? No, this has more to do with a couple things. Make sure they're ceramic friendly. So usually we're going to use diamond discs, diamond burrs. If you're using diamond discs and you're doing a bridge, just make sure that you are not cutting into your interproximal areas with a disc too deep, because you're basically creating a split in that interproximal area where that it's almost like taking an axe on a wood and hitting a piece of wood and creating a slight crack in the wood that eventually can open up. So by using a disc, you don't want to have a crack where you've purposely put in by using a disc. Now you can use a disc to contour the embrasures, but then I would use a small diamond burr that's round and kind of grind out your interproximals a little bit deeper, but you're keeping it more bowl-shaped than a V shape, wedge shape. So make sure that you use the proper instrumentation, and then I would also use caution you. Make sure you use some water. We can use the hand speed, slow hand speed, but make sure that we're going to add water to the sprue, to the material as you're cutting, as you're burring, so that one, it acts like a lubricant, but two, it acts a little bit like a coolant, if you will, so that you don't overheat any glass ceramics. And this is not just on the Ambria or lithium disilicate material, but this is really for any ceramic material that you're milling into. So make sure you're cautious on the materials that you do use. All right, we have another one that here I get fins sometimes after I press. Kind of went over that when you're talking about fins or where that you're seeing a lot of those penetration of your pressed material beyond the contour of your wax up. That could be a couple things. It could be the microfracturing of your investment because you put it into your burnout furnace where that the ring is too cold. So you want to make sure, again, that follow that process. The ring is almost too hot to handle. After you take it out of the former, you let it bench sit for 2 or 3 minutes after that, but then you put it into the burnout furnace while that ring is still hot. If it feels cold, you went to lunch, you forgot to put it in, do not use a burnout furnace at 850. You either lower it and wait until it gets down to about 700, let it heat soak for about 30 minutes, and then raise it up to 850, or have an additional burnout furnace that you're going to transition from one to the other. The other thing is maybe you're using too much water in your liquid powder ratio. Make sure that you don't break down that investment, and or maybe you've left the ring in the furnace way too long and it's starting to break down. Do I need to temper it? I mentioned that's something that VITA thinks that it should always be done. If you're not trying to do a crown in an hour, then you might as well temper it, add that extra strength. It does help in the strength. It helps smooth that surface out, kind of wets it and smooths it out. Especially if you're going to start going thinner and thinner in cross sections of the material thickness, that additional strength will certainly help. 3-unit bridge, it will help in the connector areas. and making sure that that's nice, smooth, and so forth. So it's less likely that you're going to fracture a connector area and so forth. The other question, does the Ambria come in multicolor? At this point, no, we do not have a multicolor Ambria. I know that there's a few out on the market. Sometimes they're technique sensitive. What we've tried to do is produce a translucency mix in which you've got the base color, you've got some translucency, but if you need more and more contrast, you can use the stains and the chroma stains down by the cervical and then have a contrast of enamel-like in that incisal area as needed. But a multicolor, you also need a different sprue configuration. If you don't do it just right as that multi-color pellets melts and you start pressing it, some of the color can distort as it's pressing down into the channels. So make sure that you, if you do go to a color pressable material, that you've got to have all the right tools, the right muffle. You got to get a whole new set. So, but at this point, no, VITA does not offer it. But you know, we'll see how the market goes. In Celtra, I've heard fractures if you're using pegs. Is this true? How can we avoid this? So when it comes to Celtra, which is a Dentaply Zirconia material, the Celtra material, whether it's Celtra Ceram or the Celtra Duo, which is a milled stuff, the Celtra Duo, Celtra Press, what happens is that different materials retain different heat. This is the thermodynamics that us as technicians we should be used to. Different materials are retaining heat differently as it goes into the furnace as processing. And there are some materials that you have to add a whole bunch of PEG or insulation material inside the crown to prevent it from overheating and therefore having marginal creep. And it also, during the cool down phase, it helps slow down the discrepancy between your furnace heat temperature and the material. So if your material cools down too quick, that's compared to the furnace, the muffle, or vice versa. When you have the material and the muffle really not working with each other during that cool down, you can get that fracturing. When it comes to the milling part, if it's a Celtra Duo that's milled, primarily you have to go through a glazed tempering process to reduce that the milling striations, all those milling grooves that are now milled into the material, and that'll cause the fracturing. Our materials, we make them all that we don't have to use excessive amount of PEG material to surround the restoration, to insulate it. We usually just have enough PEG material that's on the pin, put it on the top of the pin, and then insert that into the crown just so the pin doesn't touch the material, and then do a traditional cool down. And a reminder for some of you that are not necessarily went through maybe a school or had formal training, if you will. When we're talking about slow cooling, there are materials that require what we call a slow cool. For instance, look at zirconia. If you've got a large bridge, zirconia bridge, and you've layered porcelain, you have to leave that framework with the porcelain in the furnace with the muffle closed until it reaches around 600 degrees Celsius. Then the muffle can open up.
If you don't, the cool down, if that muffle opens up before it reaches about 500 degrees, that zirconia is such a poor heating, the heating conductivity of that is so poor that it is super hot. Your porcelain cools down too quickly, and it's got too much compression or tension. In this case, your ceramic is frozen on top of a continuing shrinking zirconia, and it will cause tension and it will cause fracturing of your material as well. So make sure you adhere and understand what materials, what circumstances you do need to slow cool, create a slow cool. Any more questions? Please feel free to get them in there. The next question was, after pressing, do I lower it into the, do I lower the temperature for staining glaze? That must be what it is. Yes, once you always have a high processing temperature, and then anything subsequent to that is lower. Generally, they're about 100 degrees lower, but in our Ambria, we press at 880, 890, that general area, but then we glaze it around 800. So once you stain and glaze it, you're going to lower that temperature like everything else, so that you don't distort your main set material. So, all right, so I hope that helps with all the questions. I don't see any more coming in. If you have any more, please send them in now and I'll answer it. Otherwise, I want to thank everybody for joining us today and listening to some of this information about the Ambria, the VITA press material. It really is a very nice material. It presents very well clinically. It looks very dynamic. So you got everything built into it. You know, you've got the shade consistency, you got the strength. It comes in 3D master and classical shades as well. And then we've got everything that you need around a press material to try to give you the best materials to get the best process, clinical case, and very aesthetic as well. So I want to thank everybody again, and I want you to have a nice day wherever you are. Make sure you do visit our VITA North America YouTube channel or our social sites. You will see quite a few different videos, webinars. You know, people like Felix Pages has done them for us. Victor Castro, Peter Peasy, Dr. Julian Caneo. If it's dentures you like, doing denture teeth, Mark Wagenseal. So we've got dozens and dozens of various key opinion leaders that we've done these remote webinars with and videos that you'll be glad you took some time and looked at. And if you have any questions, please feel free to give us here at VITA North America. At this time, we will conclude today's webinar. So again, thank you very much for joining us, and we will see you again sometime in the near future. If not in the field, we'll see you again maybe on another VITA Learning webinar. Thank you for joining us today. This ends today's webinar.